Hello friends. In this video, I'll be covering the remaining questions of my third internal data science examination. So let's begin. Question 1 says, what is the main purpose of data imputation? To remove records with missing data, to estimate missing values based on available data, to detect outliers in the dataset, to convert categorical data into numerical data. So basically, data imputation is the method to estimate missing values using values based on available data. We use mean, median, k nearest neighbor, and the skewed distribution using variance or standard deviation. Second question is, which of the following methods is commonly used in outlier detection? K-mean clustering, Z-score, random forest imputation, or D man mix scaling? So the answer is Z-score. Third question is, which statistical distribution is commonly used to model the number of successes in a fixed number of independent trials with the same probability of success? Normal distribution, Poisson distribution, binomial distribution, power law distribution. So the answer is binomial distribution. What does mean value imputation assume about the data when filling values? Missing values should be replaced with a value that most accurately represent the missing feature. Missing values are randomly distributed and can be replaced with the random number. Missing values should be filled using the values of the nearest data points. And the fourth option is missing values are best fit unfilled and execute from the analysis. So the correct answer is option A. Missing values should be replaced with a value that most accurately represent the missing features, because we have to basically fill the value with the most accurate value that can be filled by using the different methods. K nearest neighbor is the best method according to me. The fifth question is, which of the following is a common technique for filling missing values when using mean value imputation? Replace missing value with the mode of the data, replace missing value with a random value, replace missing value with the mean of the known values in the dataset, and replace missing values using the nearest neighbor of each data point. So the correct option is C option, replace missing values with the mean of the known values in the dataset. Now, the next question is, what is the bias variance trade-off in machine learning models? The trade-off between accuracy and computational complexity, the trade-off between underfitting and overfitting, the trade-off between precision and recall, and the fourth option is trade-off between supervised and unsupervised. So the correct option is option B, the trade-off between underfitting and overfitting, whereas increasing model complexity can reduce bias but increase variance. Now, the next question is, which of the following is a feature engineer technique used to handle categorical data? Binding the data, mean value imputation, one-hot encoding, random value imputation. So the correct answer is one-hot encoding. Now, question 10 is, after performing data imputation using the mean, you notice a significant skew in your feature distribution. What would be an appropriate next step? Leaving the data as it, since imputation with the mean is a widely accepted method, try imputing with the median to reduce the effect of skewness. Remove the feature from the dataset to avoid skewness and apply one-hot encoding to transform the feature. So the correct is try imputing with the median to reduce the effect of skewness, because mean can contain the outliers in the data which will affect the model performance. Question 11. A dataset with missing values contain both continuous and categorical data. Which of the following imputation methods would be most appropriate for the categorical values? Mean value imputation, heuristic based imputation, nearest neighbor imputation, and one-hot encoding. So the proper is heuristic based imputation, because categorical data we can generally choose a random value to fill it. Now, the next question is, in linear regression model, if the coefficient of the predictor variable is zero, what does this imply about the relationship between the predictor and the response variable? There is a strong positive relation, there is a weak negative relation, there is no linear relationship, the predictor is irrelevant to the model. So the correct answer is C option, there is no linear relationship, because if the slope is zero, then there will not be any relation between the y and the x variable. The 13, you are using feature engineering to improve a machine learning model. Which of the following strategies could help improve the model performance? Ignoring domain knowledge, reducing the number of features, creating interaction features. D, using only the raw input data into without transforming or scaling. So the correct answer is C, creating interaction features such as the product of two variables. Now, the next question is, when conducting feature engineering for machine learning model, which of the following would be considered as best practice. Create as many features as possible to increase the complexity of the model. Transform raw data using domain knowledge to create new meaningful features. Option C, apply random value imputation. Option D, rely solely on automated feature selection without human input. So the correct answer is B, transform raw data using domain knowledge to create new meaningful features. The question 15 says you are building a model to predict housing prices and you are using a parametric model. Which of the following is an assumption made by the model? The relationship between input features and output is unknown and flexible. The relationship between the feature and output is linear and fixed. The model will dynamically changes its form based on the data. And the option D is the model has no assumptions about the distribution of data. So the correct answer is the relationship between the features and the output is linear and fixed. So basically, it makes the uh, relationship as the linear relationship y equal to mx plus c and calculate the output using the parametric model. So guys, this is all from the video. I have covered all the 30 questions from my third internal data science paper. Thanks for watching. Bye.